Hello students, good morning. This is our first video lecture session. In this video session, we are going to see our coursework set of material, that is code number 23 CET301. Here today we are going to see basics of strength of material. So strength of material means it is a branch of mechanics that study the behavior of solid materials. We are going to study solid material behavior for the external load as well as any forces acting on the particular substance. So that branch is called mechanics. This we are saying strength of material. Basically, that strength of material deals with motion and deformation of a material under action of force, temperature, temperature change, phase change, other external or internal agents. These changes leads to some properties called that mechanical properties of a solid member. Mechanical properties in terms of ductility, the ductility we can say it is a solid material ability to deform under tensile stresses. So how much tensile stresses we are giving and resistance offered by the body with deform, so that is a ductility. So how much it offer, that we have to find out. Next, hardness of material, maybe the resistance to bending, stretching and abrasions or cutting. Say example, if you are taking a rod, that rod when we are pulling by two end, so it will get some changes according to the original strength of that particular material. So impact resistance for a member is ability of material to withstand high force or shock applied to it over a short period of time. So if impact resistance, if you are giving that any shock or high force in that particular material, so it will get some impact. So how much resistance it offer for that particular impact is called impact resistance. Next one, plasticity, that is ability of a material to deform permanently by the application of the force. So this is called plasticity. Next, mechanical properties, we can say mechanical property like fracture toughness. It is a property which describes the ability of material containing crack to resist fracture. So how much resistance it offered without any crack. So that fracture techniques, fracture resistance we can find out by means of that crack ability. Next, elasticity of a material. It is the tendency of a solid material to retain their original shape after being deformed. Next, endurance strength or fatigue strength. It is a stress that material can withstand for a given number of cycles without breaking. Say example, it is endurance strength. So if we are giving more fatigue load cyclic wise, again and again we are giving one load, means if it taking any material withstand with the number of cycles. So next, endurance limit, mostly the fatigue test we are conducting in laboratory, and the maximum stress which can be applied to material for an initiate number of stresses cycle without resulting in failure of material is called that endurance limit. Next, creep coefficient. It is a ability of material not to deform permanently or slowly under the influence of mechanical stresses. So creep mostly we can say long-term strain. So creep means time-dependent deformation. It's based on mass of the member also. Next, the creep, that slow deformation. The reasons behind this creep, is long-term stress belong yield resistant, so that material subjected to long-term heat when in operation maybe working condition near to melting point of the material. So total time of the use also one of the reason. And creep is a time dependent phenomenon, that stages of creep will be like this, that is primary, secondary and tertiary creep. So that primary will have a lesser amount of changes, that means the strain will be very minimum. In a third stage it will have a maximum strain. So what are all the learning purpose in this? We have to find the pressure and stress for a particular solid members, and different types of stress we have to discuss, and what is strain, how strain and stress that can correlate according to Hooke's law, and stress and strain diagram. First, that force applied on fluid will create the pressure. It's look like this figure. That is, if we are applying force in a liquid which in a container, so it will offer pressure inside the container, and it will give the circumferential pressure. So that we can say a pressure. Pressure we can measure by force by area. Same like in a solid material, how we are applying any load, that load will produce a stress. So that stress, it may be a tensile stress or compressive stress, according to which kind of force we are giving for that particular solid member. So the stress always, it is force required to produce unit deformation. So we can mathematically represent that force by area as a stress. Next, differential stresses. So that differential stresses we can take in two category. One is axial stress, another one is transverse stress. So axial stress, mostly tension or compression, it will produce to our solid body. Transverse stress, mostly it produces bending and torsion. See in the first figure, the transverse load, that means that load applying method they are giving in a perpendicular to the cross section, so it will produce only pure compression to our member, and also that that will not create any torsion. So if axial force acting, so only compression or tensile is possible. If transverse load acting, there is a possible of bending and also torsion. Mostly transverse load in a form of horizontal or inclined wise. Next, axial stress, that is tension or compression when we are giving in axial in a particular center point of our member cross section, so that it will produce tensile stress, that is stress equal to resisting force offered by a solid material with respect to area of the solid member. So this unit for stress is unit Newton per mm squared or Newton per meter squared. A transverse stress, mostly bending stress or torsional stress. So bending stress, due to bending load, deformation is occur. See here, one cantilever beam is there. In that beam we are applying a end point load, so it will produce a bending of our cantilever beam. So that bending due to this external force will create the maximum bending at its support. So this we are saying bending stress. Same like torsional stress, that due to torsional load, if we are twisting the member, that means by means of rotational force we are applying for a particular member, that rotational force will create torsion to the member element. So it will give more twist effect in our solid material. So stress due to parallel loads. mostly this parallel loads will create shear stress or shear in our members. So shearing stress mostly lateral wise it will occur. Say example here that bearing stress will occur in a rivet. So here on rivet arrangements they given between two plates. So that plate will get tensile of two sides and it will get the horizontal bearing stress. So tearing stress maybe in a same direction force will act. So strain is a relative change in shape of the shape or size of particular solid member with respect to the unit. So here there is no unit for strain. So we can say that strain means change in length by original length of a material after applied forces. So Hooke's law, it states that within within the elastic limit, the stress is directly proportional to strain always. So every material will have some um, elastic limit. So that elastic limit, within the elastic limit, we are giving any force that will not produce any uh, directly indirect proportional to the stress and strain uh, relations. So that stress equal to Young's modulus into strain, whereas modulus of elasticity E is strain by stress by strain. So it is a material property which show how much external force it can withstand for mild steel. Modulus of elasticity mostly we are taking 200 gigapascal. So stress strain curve mostly for brittle material it will be like this. So it won't have any indications or any stages. So suddenly it will break. For ductile material we have a different stages. That means yield stage, breaking stage, like ultimate and breaking. So we have three stages for ductile member. So the shaded area of this particular figure is a feasible region for Hooke's law. After that, it not have any obedience of Hooke's law because that strain is increasing without a stress relation. With this, I am stopping this session today. We will discuss further in our next session. Thank you.